When we're talking about special solutions or special cases, we're talking about times when there is not one single solution. When we're looking at special cases, we don't know that it's a special case until the end of our inverse operation process. So you're solving the equation exactly like you would for the normal case, but you just end up with an end state that indicates to you you have a special solution. So in this particular case, for example, I'm going to follow my DCMAM process. Distributive property, nope. Combining like terms, yes. 2x minus 4x. So I needed to combine like terms, and now I will move my variable term. That means I will add 2x to both sides of the equation. So it's only now that I know, oh, I have a special solution. I ended up with not x equals a particular number, but number equals number where those two numbers are not equal. -1 does not equal 9. Ending up with this case where I have a statement that is not true, -1 equals 9, that is how I know I have no solution. No solution means there is no value of x that I can plug into this equation and end up with a true statement. Looking at this line right here, it makes sense. -2x minus 1 equals 9 minus 2x. I'm multiplying x by the same number, -2, on both the left and right hand side. But then on the left, I'm then subtracting 1. On the right, I'm adding 9. So there's not going to be a number that I can multiply it by -2 and then subtract 1 and get the same thing as multiplying by -2 and adding 9. That's never going to happen, no matter what value of x I try. So this is my first special solution, which is no solution, my first special case. So if you end up in this state where a constant equals another constant, and they do not in fact equal each other, you write no solution. And no solution is your solution. You're not going to circle -1 equals -9. That's not your solution. That's just your justification. So the fact that -1 does not equal 9 is important, but it's not your answer. No solution is your answer that you should circle or box. Sometimes students get to here, and then they either add 1 or subtract 9 from both sides of the equation. This isn't terrible. It's not what we prefer, but it's not terrible. You can do it. You can add 1 to both sides or subtract 9 and end up with -2x equals 10 minus 2x. Then you're going to have to add 2x to both sides still. So you notice you end up still having to do that, and you end up with 0 equals 10. If I would have subtracted 9 from both sides, I would have ended up with -10 equals 0. So I still end up with this justification, this work, that a does not equal b, 0 does not equal 10. And I could still have used that process to arrive at the answer no solution. But you'll see that this, two steps, is much more efficient than first taking care of the constant with inverse operations. So really, we want you to remember to move the variable term first, and then you have a much shorter process. This is acceptable. It's okay. You're still correctly using inverse operations. It's just preferred to move the variable term first.